Good day, my highly esteemed viewers, and welcome back to class. Last time, in our last video, we carried out an experiment on titration, and we also did some calculations on it. But that calculation was not completed because we are not able to solve all the questions. So we now shared into two parts because of time. So the first one was part 1. Now we are going to part 2 of it. Remember, my name is still Israel. If you have not been subscribing to this channel, kindly subscribe and also help to share it. Remember, your subscription and sharing this channel is what keeps it actually going. Also press the like button. So let's go to the part 2 of it. Let's start it. So you can see this is where we stopped in our previous video. We carried that calculation and we had 0.0506 mole per dm cube. So today we are going to do the concluding part of it. Let's just start from here. So the other question now is question C. The question says, calculate the mass of salt formed when 500 cm cube of B is completely neutralized by A. Mass of salt formed. When you hear mass of salt formed, it means it's a product. So let's see how the equation looks like again. This is the equation they gave us. H2SO4 plus Na2CO3 to give you Na2SO4 plus H2O plus CO2. So that's the equation. This is the mass of this is the salt formed. This is the salt. We are told to calculate the mass of the salt formed. But how do we do that? First of all, this is what we have here, CB. Our CB was 0.0506. So first of all, 1 mole of sodium tetracarbonate 4 is equals to 1 mole of sodium tetrazosulfate 6, Na2SO4. If 1 mole of this is equal to 1 mole of this, remember we are calculating the mass of salt. Therefore, 0.0506 mole of this salt will be equal to 0.0506 mole of Na2CO3. Remember, this one is SO4, Na2CO3. So it's a simple relation. 1 mole of this gives 1 mole. Therefore, this one will give you this. So that's what you have. So after having it like this, remember what we have here is mole per dm cube. So 0.056 mole equals to this. We now say the molar mass of this is what? Sodium is 23, but molar mass of Na2SO4 is 2 times 23 plus 32 plus 16 times 4. This one gives you 46 plus 32 plus 64. Let's see what that will give us. Remember, we're calculating molar mass, gram per mole anyway. 46 plus 32 plus 64 give you 142. That's the, so let's remove this since we are not doing any titration again. I'll shift this to this side so the board will be very, very visible to audience. So you have 142. So this one now becomes 142 gram per mole. That's the molar mass of this. So that's what you have. So the next one we are going to calculate is mass of salt. Remember, the question says mass of salt formed. So we are in 500 cm cube. We are going to calculate mass of salt first. You know that mass of salt concentration in gram per dm cube equals concentration in mole per dm cube times molar mass. We can discard this one on top. Let's clean them so that I have enough space. So in in mole per dm cube is what you have initially 0.0506. Remember we said this equal to this mole per dm cube 0.0506 mole per dm cube times molar mass 142. You see it, gram per mole. So this one goes with this. So let's see, 142 times 0.0506, 0.0506, we have 7.1852. 7.1852. This one is not accepted in WAEC, becomes 7.19 gram per dm cube. You see it? So this is the mass of the salt in 1 dm cube. But the question says in 500, say mass of salt formed when 500 cm cube of B was neutralized by A. We now say 1000, that's gram per dm cube, gram per 1000. 1000 cm cube gives 7.19 gram. Therefore, 500 cm cube will give you x. Cross multiply x times 1000 cm cube equals 7.19 gram times 500 cm cube. S will now be 7.19 times 500 cm cube over 1000 cm cube. Cm cube cancels, and this here 1, this here 2. So it will now be 7.19 divided by 2. You can see my calculator, see I have this the first one. I have to punch it to 0. If not, whatever I have, they will mark it wrong. Don't say they will not calculate. Even if it's 1 million script, they will calculate all, because they also have somebody checking it later, a higher authority. So you have 7.19 divided by 2 give you 3.595. 3.595, automatically 3.60, 3 significant figures. So that is how that one goes. That's 3.595, 3.60. So the next one is volume of CO2 liberated in C above at ST. Remember in C we are working with 500. We repeat the equation again. That's number D now. You have H2SO4 plus Na2CO3 to give you Na2SO4 plus H2O plus CO2. So this is what you have. Now again, they say volume of carbon dioxide liberated in C 1 mole. This one is very important to us. That's CB, correction of B mole per dm cube. 1 mole CO2, 1 mole. You see it? Then that volume we have was, thank God we still have it, 0.0506 will now give you 0.0506 mole. You understand? I hope you are getting it. Like I told you, get a sheet of paper while you are watching this video, be writing it out, then you go through it again by yourself. At the end of the day, most students that say they did very well in the exams using this my video, they say after copying it, they copy the question also, they try to solve the question and see whether if they agree with my own. When it does not agree, they go through this one again, you will do well. So you see H2SO4 plus Na2CO3, you have this 1 mole of sodium triisocarbonate 4 gave 1 mole of carbon dioxide. Therefore 0.0506 mole give you 0.0560. Like we already said, 0.0506 mole of Na2CO3 gave 0.0506 mole of CO2. So that's what we said. Remember, the CB is mole per dm cube. You now say 1000, remember CB, where we do this, was 0.0506 mole per dmq. We now say 1000 cmq is equal to, we are converting this one to 500, is equal to 0.0506 mole. So it's no more, we are trying to convert from dmq to 500 because the question says 500 cm cube of B. Therefore 500 cm cube will give you x, cross multiply s times 1000. Don't skip any of these steps, you must follow all of them in case you encounter this question or similar question. 0.0506 mole times 500 cm cube. S will now be 0.0506 mole times 500 cm cube over 1000 cm cube. Cm cube cancels, so this here 1, this here 2. We now divide that one by 2. Let's see what it gives us. 0.0506 divided by 2 give you 0.0253. 0.0253. Let's be very sure. 0.0253 mole. Remember, the volume occupied by any gas at STP is 22.4 dm3, which is indicated here, 22.4 dm3. Therefore, we say bed volume occupied by any gas at STP is equals to 22.4 dm3. Therefore, volume of CO2 liberated at STP will now be 0.0253. We are already converting this one to 22.4, so no need to write that again. Times 22.4 dm3. Let's see what we have. 0.0253 times 22.4 gives you 0.56672. 0.56672. If you leave this one for them, they'll mark it wrong. So you have to put it to 3 significant figures, which is 0.567 dm3. 3 significant figures. So that's how you carry out this kind of calculation. Viewers, remember, this calculation percentage level of it occurrence or it occurring in your exam is over 90%. But remember again, it's still prediction. I'm very, very sure that you are going to encounter this kind of question. But remember, as I said, it's prediction. So try to understand it very, very well. Copy it on your notes. Try to solve it by yourself. If you make any error, you encounter any problem or difficulty, you come back to it and consult it. Thank you for watching my video. Stay blessed. God bless you.